Good morning, students. Good morning to the second lecture of this components module 3, that is components and hydraulic circuit design. Today we are going to start with the topic that is pressure control valves. As we discussed in the earlier classes, why we are using the pressure control valves? Pressure control valves are mainly used if you want to limit the pressure. If you have any system of hydraulic system, so if you want to limit the pressure, or if you want to safeguard the pressure, safeguard your hydraulic system, you have to use the pressure control valves, because pressure control valves are having lot of applications, because every hydraulic system having a pressure control valve, because without controlling of whatever the pressure, you can't able to achieve the proper application. Okay, that's why the pressure control valves are very much having the importance in the hydraulic and even in the pneumatic systems. Okay, we will see the types of pressure control valves. First one in here, simple pressure relief valve. The first one we are going to discuss, it is the simple pressure relief valve. Second one, it is compound pressure relief valve. Next, sequence valves, pressure reducer valve, and counterbalance valves. Okay, so these 5 types of pressure control valves we are going to discuss in this whatever the pressure control valves topic. Okay, first we discuss about the simple pressure relief valve. Okay, this is the diagram of a simple pressure relief valve which we are going to see in here. In here we have a tank, it's a wall casing or a wall body, okay, which is having one knob adjustable screw where you can adjust the distance of this whatever the opening of this this was the puppet which is connected to the spring. Okay, and you can see this is the pressure line. Okay, so this is just a simple circuit where this pressure relief valve is situated. Always this pressure relief valve will be situated after the pump. Okay, this is the pump symbol, this is the tank symbol, this is the motor symbol. So after the pump you will find the pressure relief valve. Okay, so pressure relief valve is mainly used because if in the next pressure this is the pressure part where if the pressure increases in this line, so the liquid tends to move backward. Okay, this pressure is increases as the pump continuously pumps this whatever the liquid from the tank. There is no passage to move in next port, so there is some restriction. So because of this restriction, the pressure will be increases in this line. So this pressure should be relieved. It should be relieved, so it can be relieved through this pressure relief valve. So what happens, the liquid which is high at a high pressure, it is going to push this puppet. Okay, this is the puppet which is placed in this whatever the gap. So it is closing that gap. So this puppet will be opened because of this pressure of a liquid. So this opens, and whatever the liquid which comes here, it will be transferred back into the tank. So this is the tank port. You can see the tank port, the liquid comes in and it will be coming back to here. So this spring is situated like that. It should open only when the required pressure is reached. Okay, if the required pressure reaches, then only the spring opens and it will get contracted and the liquid is going to be transferred to the tank port. So like that, this simple pressure valve is going to work in here. You can see here the most widely used type of pressure control valve is pressure relief valve, because it is found in practically every hydraulic system. Every hydraulic system contains this. It is the normally closed valve. Normally this whatever the valve is in closed position. Okay, it is not in open position. Whose function is to limit the pressure to specified maximum value by diverting the pump flow back to the tank. A puppet is held seated inside the valve by a heavy spring. This is the heavy spring which is going to be used. When the system pressure reaches a high enough value, the puppet is forced off its seat. It's going to be opens. This permits flow through the outlet to the tank as long as this high pressure level is maintained. Okay, this stays open when the pressure is going to be higher. Okay, if the pressure limits, the valve is going to get closed, and like that the liquid is going to be transmitted to the pressure port. So like that this working is going to take place in the simple pressure relief valve. So we will see the symbol of this pressure relief valve. Okay, you can see the normally closed position. So this is the symbol. It is having one square with a line. This is the input line, this is the output line, and this is the arrow which is representing it will be moves here to here. So it is closed position. Okay, there is no flow, means the liquid comes here, so there is no direction, so that's why the liquid is going to be stays here. If this connects, this arrow if come to this center like this, then only the liquid flow takes place. Okay, it will be operated with respect to the spring operation. Okay, this arrow mark represents the adjustable spring. Okay, and this dashed line represents that the pressure. Okay, the pressure line, if the pressure reaches some cracking pressure, if the cracking pressure is going to be reached, then only this valve is going to open. Means this arrow mark comes here and it will opens, it will give the direction to the flow. So like that this symbol is going to be represented. So this is the normally closed type of symbol, and when it is opens, then this symbol is going to be considered. Opens when the cracking pressure achieved. So this diagram represents a graphical representation how the it is going to represent it with respect to the flow through relief to the pressure. Means the flow is going to be considered only the required pressure is going to be reached. This is the dotted line which is shown in here. It is the cracking pressure. If the liquid reaches this cracking pressure, then only the flow takes place. Minute amount of flow is taking place here because of leakage, but when the wall is going to open, so only when this crack pressure reaches. Okay, by that the if it crosses the cracking pressure, then the wall opens fully, and this is the full flow condition, where you can see here the amount of discharge will be increases in here. So like that this graph is going to represent the amount of flow with respect to pressure. So next is the compound pressure relief valve. Okay, so we have discussed the simple pressure reliever. Now the compound pressure reliever, how it is going to operate in here. Okay, so this is the diagram. So you can see this is the body of a valve which is having one main piston, or you can call it as a main poppet, or you can have the another system. It is called as a pilot spring operated pilot poppet in here, which is going to be adjustable knob. Okay, the main spring, this is the main spring, this is the pilot spring, this is the pressure line. Okay, the pump which is connected to the pressure line. Okay, so next this is the tank return valve, means the whatever the liquid is going to be transferred back to the return to the tank. So see there, when the pressure is less than that of the relief valve sitting, the pump flow goes to the system. Okay, when the pressure is less than that of the relief valve, means if it is a pressure which is not reaching the pressure of this relief valve, the pump flow goes to the system. Okay, the system is going to take that flow. If the pressure in the system becomes high enough, if the pressure is increases in here, it moves the pilot poppet of its seat. Okay, so what happens? First liquid whatever increases the pressure, it is moves, and there is a gap which is there is a hole within this main poppet. This main poppet consisting of a one small hole inside here. The liquid first moves in here and it will be transferred, and there is one more hole in here. The liquid is going to be transmitted. At first it will lifts the pilot of this whatever the seat. It is going to lift this pilot from its seat, and because of that small amount of flow takes place. A small amount of flow begins to go through the pilot line. So this is the pilot line. The liquid comes here and it will flows, small amount of liquid flows from here. Once flow begins through the piston orifice and the pilot line, a pressure drop induces across the piston due to the restriction of piston orifice. Okay, so because of this small flow, the pressure is going to be regularly reduces. Okay, so because of this whatever the liquid movement of from here to here. Okay, but still the main poppet is not opened yet here. This pressure drop then causes the piston and stem to lift their seats off seat, and the flow goes directly from pressure port to the tank. Okay, if the pressure is going to be increases, if more pressure, if the this means a small amount of pressure is going to be relieving in here, but if the pressure is still more, then this main poppet opens and the flow is going to take place from this pressure line to the return line to the tank. So like that this whatever the compound pressure valve is going to work in here. So you can see this video This is the simple pressure relief valve. This is the compound pressure relief valve. First we will see the simple pressure relief valve. What happens in here? First there is a normally closed position, liquid comes here, pressure increases, it will opens this ball valve, small amount of liquid takes place, flow takes place, and if the pressure increases still more, the complete valve opens and the flow takes place from here to here. So you can see here, it should not open till the cracking pressure is going to be reaches. Okay, so when the cracking pressure reached, automatically this valve opens and the flow takes place. So like that it happens in the this what are the simple pressure relief valve. What are the advantages? It is low cost. Okay, we'll see it is a low cost and the fast response time to the pressure spikes. As the pressure spikes, fast response is going to be expected in this direct acting. This was a pressure relief valve, or it is simple acting pressure relief valve. So we will see this compound pressure relief valve or pilot operated pressure relief valve. What happens? You can see here first. Just see here, this is the next thing. Okay, I will wait for the no flow condition. Okay, first what happens, the liquid is going to be pressurizes in here. Okay, so the small amount of liquid, it opens the first pipette, then liquid flows here. When the pressure increases more, the main pipette is also going to open and the liquid flows from main line to the this whatever the tank. So like that is going to operated. So what are the advantages you can see here? So some of the advantages is a smaller size versus direct valve of a same pressure rating. Means it is having the smaller size compared to the this whatever the direct acting valve. And what are the other advantages you can see here? Design for higher pressure. You can higher pressure you can design, and you can design for the higher flow. Okay, we will move on to the next is the sequencing valve. Okay, so as we've seen the pressure relief valve. The pressure relief valve is always used when after the pump. After the pump, you are going to use the pressure relief valve. Then it is going to be DCV. Direction control valves. But if you come to the sequence valves will be used after the direction control valve. Okay, after the direction control valve we are going to use the sequencing valves. Okay, what is the purpose of sequencing valve? You can see here, a sequencing valve is a pressure control valve that is used to force two actuator. You can see here, two actuator to be operated in sequence. Means if you have two cylinders, piston cylinders operation is there. So one for example, one cylinder is going to hold the workpiece, one cylinder is going to bend that workpiece. If it is having the two cylinder operation, it can be sequenced. Means first holding operation, then bending operation. So that both operations can be achieved by sequencing valve. So they are similar to pressure relief valves. It is similar to pressure relief valves, somewhat changes in here. Instead of sending the flow back to the tank, in the pressure relief valve what happens? Liquid is going to be transferred to the tank back to the tank. But in the sequence valve what happens? A sequence valve always flows to a branch circuit. It will transfer that liquid to the next sequencing operations, that is going to be sent to the next cylinder. So that is going to be changes in the sequence valve when a preset pressure is reached. If the preset pressure is reached, next that whatever the liquid is going to be transferred to the next cylinder. We will see in the circuit, we will understand better. Okay, we will see this is the symbol of a sequencing valve. So you can see the similar symbol. It is very simple, similar to the pressure relief valve. But you can see this is the inlet line, this is the outlet line. And always it is in a closed position. The liquid comes here, pressurizes this line, and it will connect here. And next, the liquid is going to be transferred to the next cylinder, not for the tank. Okay. So, but in the pressure relief valve, what happens? You can see in the cylinder relief valve, what happens? It is sending this liquid to the tank. It is sending the liquid to the tank. So that's why it is pressure relief valve. In sequencing valve, what happens? The liquid is going to be transferred to the cylinders, next cylinders. So that's why it is going to be used for the sequencing operation for the next operation. Okay. This is one more symbol. It will be understood by understanding this circuit. Okay. See here. So this is the direction control valve. So what happens, liquid comes here, it will move here, and it will comes to fill through this line, it will come here, and it will pressurize the piston to move left side. Okay, so this piston, so the liquid which is trapped at here, it will comes here. Okay, it will comes here, and it will move back to the tank. Okay, so like that this operation is going to takes place in here. But if this is connected to this, one more connection is you can see here, the liquid comes here and the liquid transferred to the sequencing valve. Okay, the sequencing valve, in here what happens, liquid is going to be sequenced. If the limiting pressure reaches, the sequencing valve transmits this liquid and it will sends to the next cylinder. First cylinder, this is the second cylinder, it will transmit to the second cylinder. This second cylinder, what it's going to do, it will, because of the liquid pressure, it will move downward. So first it will move here, then it will move downward. Okay, so like that, next this liquid is going to be transferred back to a tank. So this is sequencing. The pressure relief valve is using the external pressure of this line to operate the second cylinder. Okay, so this is the sequencing operation which is done by this simple sequencing circuit. Okay, it is a simple circuit, I am just explaining you to understand, but you have some complicated circuits that you have to do in your exams. Okay, so like that, and whatever the liquid comes here, if you want to the liquid, if the liquid is transferred back here, the liquid will be pushing here and it will be transferred back through this check valve. Okay, the check valve opens and the liquid is going to be transmitted back to the second sequencing. So like that, the sequencing is going to be works in here. This is a simple circuit. Okay, so this is the simple circuit where you can bypass check valve is provided. The symbol is going to be here. This is the pressure sequencing valve. Okay. Okay, students, thank you for watching. I think this circuit will be understood in a better way if you do the circuit diagrams. Okay, then only you can understood how the operation is going to takes place. Okay, so then only you can understand this circuit, and we will discuss more detailedly in that section. Okay, so we have discussed only 3 pressure relief valve. We still have 2 pressure relief valves, pressure control valves, such as counterbalance valve and pressure reducer valves. Okay, so after that we will complete this pressure control valve section. Okay, thank you, students. I hope you understood the topic. If you have any doubts, you can contact me. Thank you.